So hello and welcome to Semaphore Uncut, a podcast where we talk about continuous integration, continuous delivery, and generally developer experience and technologies. Today with us, we have Elton Stoneman. Elton, thank you for joining us.
Thank you very much. Thank you for having me. Yeah, so I was listening to your podcast recently with Brett Fisher. So you covered some container stuff. I know you guys are big into containers.
Yeah, great. Nice to hear that. Yeah, feel free to go ahead and introduce yourself.
Yeah, sure. So my name's Elton. I work for Docker. So I've been with Docker over 3 years now. I'm an architect in kind of partnerships team. So I work with companies like Microsoft and GitHub and AWS and on a technical level, showing them what we've got coming through in the products and what they've got coming through. And we work out some nice developer stories. Before I joined Docker, I was a .NET consultant for most of my career. So building big, ugly, monolithic applications that I now spend time teaching people how to break up and move to the cloud. And I joined Docker because Windows containers were a new thing. And I was using Docker in Linux on a project back in 2015. And I was really interested in seeing what was going to happen in the Windows world. And then when Windows containers came on board, then I joined Docker. And part of my job is kind of spreading the word to the Windows and .NET community about what all this cool new stuff is.
Great. And part of your job is also like teaching.
Absolutely, yeah. So I'm often at conferences speaking about what things are going on in Docker and what patterns and practices look like and what people should be considering for their architecture. But I'm also a Pluralsight author, so I've got a stack of Pluralsight courses, which is an online video training company. And I'm a book author, so I wrote the book Docker on Windows, which kind of tells you what it's about just in the title. And I'm in the process of writing another book now, which is Learn Docker in a Month of Lunches. So it's quite interesting because I'm sure you're in a similar position. You've been using containers for a very long time, and there's a point where you just take it for granted. And this is how all this stuff works and unlocks all these great capabilities. But there are a ton of people who are still really new on this. So the new book that I'm writing is very much a step by step, takes you from the beginning, takes you through some really quite advanced stuff, but it's for people who are just starting out with containers.
Great. And if you're listening to this, we'll have a blog post accompanying this where we will share some codes for Elton's new book. So yeah, be sure to check it out. Okay, so moving forward, you said that you spent a number of years building monolithic applications on Windows, and I'm sure that it's not as bad as you described it, but I get the idea. And as Docker initially started building on years and years of development in the Linux kernel and all that, and as Windows was, let's say, joining the party. So can you give us a bit of the history, how it came about, what's the current state of Docker on Windows, and just guide us through?
Yeah, sure. Like you say, the development was really interesting because Docker came along and took these primitives that have been in Linux for a long time that let you take a set of processes and put a kind of thin boundary around them and call them a container that had been in Linux for a very long time. And Docker just came along and made it super easy. And then the opposite happened in Windows. So when Docker was becoming really popular, we were working with the Windows Server team and they were really keen to bring that experience to Windows. They started the other way around. So Docker came to Linux and brought the simple developer user experience to containers. And the other way around happened in Windows. So they wanted to start with that user experience and keep it the same for Windows containers as it was for Linux containers. But then they had to go back and put those sort of primitives that Linux had into Windows because Windows never had that stuff. That's not that idea of namespaces and C groups. It didn't have anything like that. It still doesn't have quite the same thing. So actually the internals of how Windows Server container works are slightly different. But as far as Docker is concerned, it's the same. It's the same set of artifacts. So you have a Docker file to package up your application that produces a Docker image and you run it inside a container and you share those images on Docker Hub or whatever registry you're using. The API is the same. So Docker runs in the same way. It's a background process on Windows. It runs as a Windows service. And in Linux, it runs as a daemon. There's the REST API, which is how the command line talks to the Docker engine. That API is the same. The Docker command line is the same. The huge advantage is you can take these older applications that are built for Windows and you start bringing them into the modern world. And what you end up with is a really consistent set of tools and processes throughout your whole stack because everything has a Docker file. Everything builds an image. Every image gets security scanned and signed or whatever your pipeline is. And then ultimately you deploy it with Docker Compose in your test environments and Kubernetes in your production environments or whatever you're doing. But it's the same set of artifacts everywhere, whether it's your 10-year-old Windows application or your brand new Node.js application. So it just simplifies lots of teams.
That's very nice. I don't remember that there was ever the time that something worked on Linux and Windows in the same format. ever.
Well, that's one of the things I'm trying to do with this book at the moment, because you can package up your Docker images so that they run as Windows containers on Windows or Linux containers on Linux. So what I've tried to do is every example in this book is the same everywhere. So I can follow the code samples in the book and do a Docker container run. And if I'm running on a Raspberry Pi, it'll pull down a Docker image and run it on Linux. And if I'm running on Windows 10, it'll pull down a Windows image and run it on my Windows machine. And that's super easy from the user point of view, but it's much harder for me as the author of those images, because I need to make sure that little things like, the commands are different between Windows command and Bash shell, but I need to make sure that they're portable. So yeah, it puts the onus on the image author, the person who's publishing the applications, to make sure they work in the same way everywhere. But, it makes it hard for one person and easy for 10,000 people who use the images.
Yeah, yeah. Since you were in this Docker world since the very beginning, I'm just curious to know how long did it take for Microsoft to get to a production stage with generally Docker support? Because I know we have been using internally LXC containers for 10 years, and just through, pain of using LXC without Docker, containers without Docker, I just learned that all those features needed for Docker, as you mentioned, C groups, namespace, all those, that was landing in the period of 10 years. I'm just curious to know how Microsoft solved that and in what amount of time. And
Yeah, so I couldn't give you an exact amount of time that went into it. Our engineering team started working with the Windows Server team back in 2014. And then 2016 was the first release of Windows Server that supported containers. That was a production release with production support from Microsoft and from Docker. We had an arrangement for supporting containers between the two companies. Towards the end of 2014, I think, we're talking about a year or so. How much of that was actual development effort and how much of it was scoping, I couldn't really tell you that. But I think the interesting thing is, compared to the situation you were discussing where you've had your LXC containers and the pieces were all there, but people were having to put them together themselves. Again, it was the opposite for the Windows team. So they already had the Docker API. They knew what features they had to expose, and they had to bring that into the Windows kernel. Actually, the process isolation part of it, as I understand it, wasn't so complicated because there is already isolation at different levels within the kernel of Windows, and they just had another way of expressing that. The networking piece was a lot harder, I think. So the Linux networking stack is infinitely complex and pluggable, and the Windows networking stack was a lot more straightforward. But Docker took advantage of all those weird and wonderful parts of the Linux networking piece. So a lot of that had to come into Windows. So what happened was, when Windows containers were first supported, and that came out in 2016, you could join a Windows node to a Docker swarm, but it wasn't a full part of the swarm. So, the clustering technology wasn't quite there because Windows nodes couldn't take part in the distributed network. So I couldn't have Linux containers talking to Windows containers on the same cluster. And it took the first roll up patch release of Windows Server to add that functionality. And so it was in Service Pack 1 type release of Windows Server 2016 that added those networking features that then made Windows nodes in the swarm the same level of capability as the Linux nodes. And actually, the same thing has been happening now with Kubernetes. Windows support for Kubernetes came in alpha a couple of releases ago, and then it graduated to beta, and then it's finally gone into GA release now. And a lot of the things that have been fixed over the time is to do with networking and making sure that pods can communicate with each other, whether it's a Windows pod on the same machine, a Windows pod on a different machine, or a Linux pod on a different machine. So the networking stack was the most kind of complex set of problems to solve.
well, that's from the perspective of shipping such a complex software, quite an achievement to get something in a year which you can call a production ready.
Yeah, it folded into Windows 10 shortly afterwards, and Docker Desktop added the functionality to do that. Developer experience on Windows 10 is excellent because I can run Windows containers, or I can click a button and switch to Linux containers, and Docker takes care of all that stuff for me. So it's a really nice way to get things up and running.
That's great. And from your experience of working with people and with Docker, which is touching both Linux and Windows, what are some of the usual practices of using it? Are people running on the same Kubernetes cluster, both Windows and Linux applications side by side? Some nodes being Windows, some Linux?
Yeah. So that's pretty new. So the cloud providers and the kind of on-premise Kubernetes providers are either in the process of adding Windows support, or it's just gone GA. So Azure have AKS, their managed Kubernetes service. They all have Windows nodes in various levels of support. So some of them are full GA and some are currently in preview. Similarly with the on-premise ones, so I mean the major providers, Docker Enterprise and the likes of Rancher, they've got Windows support for their Kubernetes nodes now. The kind of space that I work in is talking to companies who have a similar history to me. They have a history of Windows applications and .NET applications. They want to move them either to the cloud, or they want to break them up into smaller pieces, and they want containers to be part of that journey. The pattern that is kind of emerging is you can take your old monolith and you can run it up into a Docker image fairly easily. You can package that up to running Kubernetes fairly easily, and you can push it onto AKS, and you'll be up and running in a week. But you haven't got a cloud native application. You've just got your old monolith running in Kubernetes in the cloud. But then you can start breaking it up. And as you're working on features, you're maybe going to split those into different containers. If you're in the .NET world, your old application will be a full .NET framework app in Windows pods. But the new features may very well be .NET Core apps running in Linux pods. And gradually, I think what we'll see is if I'm predominantly a Windows shop, I'm going to start off with a Kubernetes cluster that is 90% Windows nodes and 10% Linux nodes. And gradually, as my apps evolve, I'm going to shrink down my Windows estate and scale up my Linux estate for reasons of cost and efficiency and all that sort of stuff. So ultimately, I may just have, a couple of Windows nodes that are running those old applications that don't justify being rewritten, don't justify being broken up, just leave them as they are. And the rest is kind of migrating to cross-platform stuff that can run on Linux.
Yeah. I mean, obviously in 2014, 15, there were early adopters of Docker. For me, as a relatively young developer, it's surprising how big companies, enterprises are very keen on adopting Docker and Kubernetes. From what you described and from what I heard previously, it makes a lot of sense because those monolithic applications that you are mentioning, there are like tens of thousands of hours and billions of dollars potentially invested in some of those, but you need to move forward. You cannot rewrite that.
Yes, yeah, exactly. If I'm doing like a workshop who are in that position of having these big monolithic apps, they understand the advantages. They understand where they want to get to, which is certain features need a much higher release cadence because we want to get new features out quickly. Certain features are brittle and we want to make sure that we don't release them as part of some other release. All the things that you get with a kind of microservice architecture, but they don't want to take their old application, stop development for 18 months and completely rewrite it because there's very little business value in that. So the approach that we kind of work through when we're looking at this sort of stuff as some of the options is to take those known pain points. The big advantage of having a big monolithic application that's a complete nightmare to work with is that you understand why it's a nightmare. You understand the bits that are difficult. So you can start to carve those out. First release might be 90% of the code is still in that monolith, but one feature that needs rapid development has come out into a separate container. So next time I do a release of that feature, I leave the monolith as it is. I'm not going to do an update of those pods or those containers. So I don't need to do my 2-week regression test cycle. I just test the new things that I'm deploying, which might take a day or two, and I can get a release out really quickly. And gradually you take the important parts of your application, or the parts that make it difficult to maintain, and you bring those into separate features, then gradually you're realizing the benefits of the modern approaches without a big rewrite project, because those big rewrite projects are lengthy and incredibly risky.
Yeah, yeah. Now that you describe it in such a way, it sounds so obvious, but I was not thinking about that in such a straightforward way that just the release cycle can be very different. And, if you take into account maybe some regulated industries, maybe part of your application, you really don't want to touch them for many months or have, a quarterly cycle, while on the other parts, you can just run freely.
I mean, there are some good indicators of the pieces that I pull out of my monolithic application. One is the things that I need to change regularly. But like you say, the other part is the things that don't need to change very often. One of my consulting gigs was at an investment bank, and we had like a third-party service that we consumed. It was really complicated, nasty code because their API wasn't very friendly, and they only ever changed their API once a year. But every time we did a release of the software, which was only sort of 5 or 6 times a year, we had to make sure we regression tested all that component. We had a huge suite of tests for it because if it failed, then things were catastrophically bad. But if we could have pulled that out into its own feature, then we would only release that once a year when their API changed. We would save all that testing time and all that risk. There's some nice approaches that this stuff just makes easy to do.
Yeah, yeah. If I'm completely new to Docker, to Kubernetes, from your experience, what are some advices that you can give? What's the best way to get started?
Well, So the learning path really is start by running a container. So get your head around the concept of a Docker file, which is just a script that packages up an application, building an image, which is really just like a big zip file that contains your entire application. You can share that around, and running single containers and getting comfortable with the Docker commands and the Docker file syntax. And that stuff's actually pretty simple. I mean, the Docker file syntax, you only need to learn 4 or 5 commands, really. Anything complicated that you need to do to set up your application inside the Docker file, you'll be using Bash scripts or PowerShell scripts anyway. So you're going to take through some of the skills you've already got to package up your application. And the Docker commands, it's a Docker run to start your application. You can publish the ports so that you can send traffic into your containers. They're a fairly streamlined set of things that you learn. And the next stage is multi-container applications. So whether you've got an application that has an API and a website, or an API and a website and a database, and add in a message queue or whatever, then you learn Docker Compose, which is how you describe a distributed application. And again, it's a new thing that you have to learn, but it's fairly straightforward. So the Docker file is a script that describes packaging up one part of your app, and the Docker Compose file describes the structure of your application, all the different parts. So I have my API container, I have my web container, and then you get to feel what it's like to deal with distributed applications in containers. And that's often where people start to really click how valuable this stuff is, because when you start to do this as a new starter on a project, you're going to browse to the GitHub page, clone the code, and you're going to run Docker Compose up, and that's it. The whole app will be running on your machine the same way that it runs in the test environment and the CI environment and everywhere else, because it's all been codified in these little script files on the Docker Compose file. And then the next step is, what do we do from there? Because Docker Compose is for running a multi-container app on a single machine, on your dev machine or your CI server or whatever. And then that's when you get into I need to choose an orchestrator. Kubernetes is the default because there are managed services everywhere, but Docker Swarm is an alternative. It's worth looking into Docker Swarm because it's part of Docker, so it's easy to get up and running, and it's much simpler to work with than Kubernetes because it uses that same Docker Compose structure. So I can take my Docker Compose file that I'm comfortable with, that I use in my dev environment, and I can use the same thing or a modified version of that thing to deploy to production. And then if you've got comfortable with Docker Swarm, then learning Kubernetes is easier because some of the concepts come with you. So, the concept of a cluster. Now I've got a whole bunch of machines that all run Docker. I don't start individual containers. I take my application description, which is this YAML file, and I give it to the cluster, and it works out where to run containers. Fundamentally, all the orchestrators do the same thing. But there are levels of complexity that you can dig into, and you can spend months learning Kubernetes. So I think the important thing there is, there are some key technologies. So you're going to learn Docker because no matter what your end goal is, the containers are where all this stuff starts. You're probably going to learn Compose because that's how you describe your application. And then you're either going to go the Swarm route, or Nomad from HashiCorp is another container orchestrator, or you're going to go for Kubernetes. But it's not a fixed journey that you have to go all the way to the end and become a Kubernetes expert before you take this stuff into production. When you're happy with Docker Compose, you can do that. You can run single containers on single servers if that's going to get you some value, because if you're currently running every app on a VM and those VMs are running old unsupported versions of the operating system, then moving to containers and running Docker Compose on your server is a big step forward. It's not microservices, and it's not highly available, and it's not super scalable because you need a cluster for that, but it's still better than you've got today. So the journey is kind of Docker, Compose, and then Swarm or Kubernetes. But you don't have to go all the way. You can stop where it makes sense and then move on to the next step when you're ready.
Just to confirm, that was the journey that most of the people take and that we also took. And yeah, I can say it works. Yeah, Docker Compose was kind of a surprise for me because for a developer day-to-day life, it makes it so much better.
Yeah.
You don't have to worry how to install a very specific version of Redis or Postgres or how to do that networking stuff, but that's a couple of lines of that Docker Compose file and it just works. The last thing that we talked about preparing for the episode is generally what's the next step. And you mentioned something which is very interesting, which I don't know much about, and that's generally the cross-platform images. So you can get us up to speed. Where is it going?
So one of our partners at Docker is ARM. They don't make chips, but they make chip blueprints. So practically every mobile phone in the world has got an ARM processor. They're probably best known on the desktop with the Raspberry Pi. So the processors are super efficient, and they run very lightweight in terms of the energy use they require and the heat they produce. So there's a move towards looking at bringing these things into the data center. So suddenly there's all these different devices that are either IoT devices or edge devices or potentially data center devices that are running ARM CPUs. And that CPU instruction set is completely different from the Intel instruction set that everyone's been using for the last 20 years. So you need to rebuild your apps to run on ARM, and not every application platform works on ARM. So most of the modern ones do. So anything like Node.js, Go, .NET Core, Java, obviously, they all work just fine on ARM. But the developer experience is pretty bad because typically you're going to connect somehow to your Raspberry Pi, and you're either going to have a USB cable and you're going to send the code down there, and then you'll log on to the Raspberry Pi and do a build, and that takes forever because the CPUs are fine for running apps, but compiling is quite an intensive process. And then you need to find a way to ship that application, and it's just a difficult experience. But then Docker started working with ARM and realized that actually the artifacts that we have to build your application, like the Docker file, that lets you be cross-platform. Because if you're new to all this, then your Docker file is how you package up your image, but you can also compile your code inside your Docker file. So you don't need to have an SDK with a Go compiler or the .NET compiler or anything like that on your machine. That can come in a container. So that container can compile the code for you and produce the output and then package it up to run in another container. And that means it can work across any platform. So if I'm running on Windows, then when I'm building my code, it's going to build using the Windows compiler. If I'm running on a Raspberry Pi, it can build using the ARM compiler. And the output I get will be a Windows version on my Windows machine and an ARM version on my Raspberry Pi. But what Docker Hub lets you do, and what the Docker registry, which is how you share these things, it lets you share an image in such a way that it has a single name. So I'd have my application called six-eyed slash my app. Six-eyed is my username on Hub. But that's like an umbrella name. And underneath that, there are different images for different architectures. So when I do Docker run six-eyed slash my app, if I'm running on Windows 10, I'm going to get the Windows 10 version, and that will run as a Windows container. If I'm running on a Raspberry Pi, I'll get the ARM version, and it'll run my app as a Linux container. But Docker takes care of all that stuff for you. So as part of the image metadata that goes and lives in the registry, it contains the operating system and the CPU architecture. And when you're running your Docker engine, it knows your local operating system and CPU architecture. So when you pull an image, or when you try and run a container and it pulls an image for you, it'll pull the one that matches. So it just takes care of all the complexity for you. Again, as the image author, you need to be aware that there are differences between some of those platforms, and you need to allow for that. But ultimately, you're publishing one thing and you're letting people consume it in different ways. So it becomes super simple. We did a demo at DockerCon, which is the big Docker conference. We had a Docker file to build this Java application and run it, and we were running it on Intel machines in AWS. And then we took the exact same Docker file. We spun up an ARM virtual machine in AWS. They have these instances called A1, which are running ARM CPUs. They're about half the price of the Intel equivalent. We took that exact same Docker file and we built it on that A1 machine and ran it on that server. And we didn't have to change a single line of code or a single bit of the Docker file. We just had our app running at half the price that we were previously paying. So you need to have your application that will run on any architecture. So it needs to be certain platforms that support it. But if you get there, it's a super good way of doing these things. And that's just the data center use case, because of course, if you're building something for an IoT device, one of the biggest problems is how you ship software out, how you can reliably get the new update without having to restart the machine. If your application is running in a container and you're using Docker Hub to distribute, all that stuff's taken care of for you. So there are some really nice use cases around what you can do with ARM.
Yeah, you mentioned IoT and data centers, of course, but maybe for all the desktop software that's cross-platform, that's also quite useful, probably.
It depends what you mean by desktop software, because not everything has a UI. If it's a web interface, then yeah, absolutely. It just all works in the same way. If it's trying to interact with the graphics subsystem, then you might have a more difficult experience.
Okay. Do you maybe have anything that you're looking forward next year in terms of Docker? What are some features that you're looking forward?
Yeah, so we've got some new features that are really cool in Docker Desktop, which I've been working with lately. We have this thing called templates, and a template is the notion that I can go into Docker Desktop and I can use a template to bootstrap a new application. So I can pick a template that's got a .NET Core web app and a Go REST API, and it uses Postgres and Redis. And I click a button and it spins up all the stuff for me. So it spins up some demo code, plus the Docker files, plus the Docker Compose file, and I can run that stuff up and see it all working locally. We've had that for a little while, actually, those templates. But to generate the template on your machine, you can do anything because those templates run inside containers. So in theory, you can put anything inside those templates. And I've been working with stuff like GitHub Actions and the Azure command line so that when you spin out your template, not only can you run everything locally, you can push it to GitHub and it will create a Kubernetes cluster as your Postgres database. It gets the connection string from Postgres and creates it as a secret in AKS. It deploys your application, just does everything for you. And again, there's a certain amount of work that the template author has to do to get that experience, but the user is just, you're literally clicking, putting in some details, and you get all this stuff for you. A lot of people are very interested in that, ranging from people who do the kind of job that I do, which is going and showing people how your applications work, because it's really easy to wrap up a demo and show it to people, right the way through to architects in big enterprises who want to take all their best practices and put them into a template that's reusable, easy to discover, and that they own. So, when their devs need to spin up a new service that they're going to package into their application, they know it will contain a health check. They know it will contain a metrics endpoint because all that comes from the template. So that's super powerful. And that's the ongoing ubiquity of these things. So, everything runs in containers. So your GitHub Actions that I mentioned, Azure DevOps, all the kind of CI things, they all run in containers. So you take your tools and wrap them up and they run them anywhere. And then the ubiquity we're seeing around Kubernetes, you can run Kubernetes through Docker Desktop on your Windows or Mac machine, and it's a real Kubernetes single node cluster. And we're just seeing that stuff everywhere. So if you look at the Cloud Native Computing Foundation, they have this landscape where they plot out all the interesting technologies in the space. And there are hundreds, if not thousands of things there. Actually, they're all powered by the fact that you have Docker containers, you have a cluster that can run everything in high availability and scale with Kubernetes. If you're in the beginning of that journey, it is a learning path and there is complexity you have to get your head around with those things. But once you learn Docker and Kubernetes, everything else uses that stuff anyways.
And whenever we are spinning a new microservice, you kind of have that boilerplate, which always rots. This is something that could, take that to maybe a next level.
Exactly, yeah. And we're also thinking about the life cycle in terms of, I've created my new microservice from the template. So I've used template version 1.x, and several months down the line, do we want to have the features in Docker Desktop that will allow you to rebase that template, and upgrade your boilerplate code to the latest template? So we're looking at that stuff. So yeah, there's some interesting things coming down, I think.
Yeah, sounds great. Looking forward to it. Thank you very much for your time. It was a pleasure talking to you.
And you.
Bye.
Bye.